And great job, guys. Abigail, Ethan, William, Alexander, Aaliyah, Emery, Dax, Emily. You did extra work. That's awesome. Way to go, guys. Okay, just so you guys know, I can see I have like a little thing and I see like who's working in the course, who's actually submitting assignments. And I get so proud of you guys whenever I see your names on like who's working in the course. So keep up the great work on that. And just know you can always come ask me for help anytime you need help with any assignment at all. So keep up the great work on that. If you are new this week, welcome to chemistry. There is a link to these slides in the chat. You're going to want to click on the slides today. So let me go up and find that link in a second. Give me 1 second. If you just joined, did I send the link in the chat? I feel like I did. There it is. Okay. Okay, so click on this link right here if you have not yet. And that's the link to this. And then download a periodic table. I think the black and white one is actually the best so that you can add on to it. But save it and print it if you have a printer. But make sure that you save it and refer to it because it'll really help you in the course. Okay, and this is the resource folder. So if you haven't clicked on that yet, click on that and you'll see access to all sorts of like videos, tutorials, things like that for each lesson. Some of the lessons that are harder, sometimes in the tutorial videos, I just straight up go through the problems and give the answers with you and work them out with you. So on some of the harder lessons, just know, look at my YouTube channel because on my YouTube channel, I go through the lessons that are harder and help you out with them. Okay, so last week we kind of started talking about ionic and covalent bonding. Do you guys kind of remember talking about that, about the differences? Or is it like, it's been a week, we don't remember much at all about it? Natalie remembers it some. Okay, that's awesome. We learned that covalent molecules, they share electrons like this. So for example, water looks like this at an atomic level. They share their electrons so that everybody has a full shell. Every atom wants to have a full outer shell. Covalent molecules do this by sharing electrons so that they all have a full shell. But covalent molecules only happen between non-metals. So you can't have a covalent molecule if it's a metal in a non-metal. It's only for non-metals. So it's like exclusive. There's like a club and you've got to be a non-metal to be in the covalent bonding club. Okay. So here's how you know the red are metals and the blue are non-metals. Okay, so if you're covalent, it's kind of this exclusive club situation over here where you've got to be a non-metal to be a covalent molecule. We learned about how many valence electrons there are, and you can put this on your periodic table and explain to yourself what these numbers mean. The numbers in each column tell you how many outer electrons every element in that column has. And we talked about how you can draw dots. So like 1 dot means that there's 1 outer electron. 2 dots means that there's 2 outer electrons and so on. So you can draw dots to kind of show what's happening there. And then we talked about ionic compounds. Ionic compounds happen where 1 electron, 1 metal donates an electron completely. So rather than sharing, they completely transfer over. So the green Na is giving away its electron, if you see there, to the chlorine. And so the chlorine now has its electrons. So they're not sharing, they're donating and receiving from one another. And this is an ionic compound. And this happens between a metal and a non-metal. So you've got to be a metal and a non-metal for ionic compounds to happen. Okay, so there's ionic and covalent. Today we're going to talk a little bit about how you name them. But we're going to do a practice real quick. So I'm going to have you look at your periodic table, get out your periodic table, and tell me if this substance is ionic or covalent. So remember, ionic is between a metal and a non-metal, and covalent is between 2 non-metals. You may want to go back actually to this picture, right? This picture kind of shows you the colors of what each one is. So for CH4, we've got to find a carbon and we've got to find hydrogen, right? So does everybody see carbon and hydrogen on the periodic table? Is this between a metal and a non-metal or 2 non-metals? Yeah, they're both non-metals, right? So is this going to be ionic or covalent? They're both non-metals. So because they're both non-metals, Alexander, you are correct. Great job. They're going to be covalent because two nonmetals make something covalent. Let's look at this one right here. So Zn and I. So we need to go find Zn and I on the periodic table. And we have to decide if it is ionic or covalent. So what do you guys think? Do y'all see Zn and I? Alexander is saying ionic. So he's saying it's between a metal and a non-metal, right? Yeah, so it's going to be ionic because do you see zinc right here? It's a metal, and I right here is a non-metal. And so together that makes an ionic compound. Great job. Okay, so today we're going to learn about how to write formulas for ionic compounds and how to name them. Okay, so we're going to start with magnesium chloride. So when you're writing a formula for an ionic compound, first you have to figure out the symbols. So we need to find the magnesium and the chloride on the periodic table. So looking here, you'll see that this right here is magnesium, right? And this over here is chlorine, which it changes to chloride whenever you name it. So do y'all see magnesium and chlorine there? And so we know that we need to figure out their charges now. So when you look at magnesium, what charge does magnesium have? Yeah, Emily, I agree. Natalie's really quick with that. Yeah, great job, Natalie. Do y'all see how Mg has a +2 charge? And what charge does chlorine have? What charge does chlorine have? You'll look at this sheet here. You see how it's in this column right here. It's got a -1 charge, okay? So we're going to write that down. We're going to write down what charges they have. And we know that the net charge needs to be 0. So a quick way to figure it out is to cross over the charges. So look at my arrows here. We're going to cross them over, and the 1 is going to go with the Mg, and the 2 is going to go with the chlorine. And so you don't cross over like the positive negative part, but you cross over the number to make it MgCl2, right? So that is what will make the net charge equal 0. You got to confirm that the net charge equals 0. You can do some math to figure it out. Like, okay, MgCl2, I have 1 magnesium with a +2 charge, and I have 2 chlorines with a -1 charge. And so that comes out to 0. So basically crossing over the charges is going to make sure that the net charge is 0. And you can do like a math to confirm that, to make sure that you've done it correctly. Another way to look at it, like I just kind of look at it this way, like magnesium has a +2 charge and chlorine has a -1 charge. So when you have 2 of them, right, then they're going to net out to 0. Does that kind of make sense? Making a little bit of sense here. We're going to do a little bit more practice with this. All that we're going to do today is ionic formulas. Okay. Okay, we'll go slower. Let's do another practice problem here. So we need to write the formula for aluminum phosphide. Okay, aluminum phosphide. So y'all go to the periodic table here and let's find aluminum. Does anybody see aluminum on the periodic table? What symbol is aluminum? Take your time for a second and see if you can find aluminum. It's kind of on the right side of the periodic table a little bit. I'll give you a hint. It's number 13. Do y'all see? So aluminum is Al. What charge does Al have? Great job, Emily. Great job, Natalie. Yes, great job, Sydney. Y'all are all seeing it. Okay, aluminum has a +3 charge. Y'all see it right here? Got a +3 charge, number 13. Okay, what was the other one? It was phosphide, right? Aluminum phosphide. So we need to find something that begins with phos, because you know how they changed to ide? So we need something that begins with phos. Okay, so I'm seeing some answers here, but look through and see if you can see. Sometimes it's hard to read. Look at number 15 on the periodic table. You see how that says phosphorus? So that's our element. It came from phosphide. What charge does phosphorus have? Great job, Emily. What charge does it have there? Great job, Natalie. Great job, Diane. Great job, Aaliyah. Okay, so we're seeing that, right? So let's go ahead and write that down. This is what we know so far. So we know that aluminum has a +3 charge and phosphorus has a -3 charge. So when you cross those over, right, you get, like you can cross over the numbers, you get Al3P3. But because they're both 3, we can reduce that. Both can be divided by 3. So our actual formula is going to be ALP. And then we just need to make sure that the net charge is 0, right? And we can see that it is because one is +3 and one is -3. So we only need one of each to make the net charge 0. Does that make sense to you guys? Give a thumbs up if that makes sense. Give a thumbs down if it doesn't, or a no, and ask the question in the chat if you want, if it doesn't make sense. Yes, Wesley, what you got?
I'm sorry. Please do not scold me for being late.
Oh, you're fine. I'm not going to.
I was in the study hall and I had to do my economics class.
No problem.
I realized I had class.
Just follow up with me afterward if you have any questions. So let's do another example here. Oh, I kind of got this out of order here. Hold on. We gotta look at this a little. Sorry, y'all. I'm a little bit out of order here. We're supposed to write. Let me edit this real quick. We're supposed to write the formula here for which one?
Toy Story or Coco?
Wesley, that's what we did earlier. We're working on something else right now. Let's see. We're supposed to write it for calcium phosphate. Okay, we're going to come back to this one because I did this out of order. If you see, like, I kind of gave you all the answers, but you can look at this if you want. For calcium phosphate, calcium has a +2 charge. Phosphate, if it ends in 8, you have to look on your polyatomic ion sheet. Okay, and that's from your chemistry reference guide. And we're going to do some practice with that in just a minute. So we'll come back to that one. So don't freak out about that one. There's plenty of examples that we'll do. Now we're going to do something a little bit different. If you notice here, when you look at this picture, what do you notice about the central elements? What do you notice about them? Like, see how we have these charges going on here? What do y'all notice about those middle elements? Anything that y'all notice? They're sad. Yeah, maybe they're a little bit sad. What you may notice, or what you should notice, is that there are no charges there, right? Like, why are there no charges for the central elements right here? These are called transition metals. So there are no charges there, right? And that's because they have multiple. Sometimes they have a +1 charge. Sometimes they have a +3 charge. Their charges vary or change. So when you have a transition metal, you have to look at the Roman numeral. So if we're doing iron 2 sulfide, okay, we have to find iron and sulfide on the periodic table, okay? So when you look on the periodic table right here, you can see that iron is Fe. Fe is a transition metal right here. It does not have a set charge. And then sulfide over here, this is sulfide right here that I'm circling, and that does have a -2 charge, right? But the way that we know the charge of iron is the Roman numeral will tell us. So if you have a transition metal, you will have a Roman numeral that will tell you what the charge is, because on the periodic table, it doesn't tell you for the transition metals. Okay. And then Ashlyn, I will definitely send you, like, I have a recording of this too. So take your time so that, you can look at the recording later too, but I will try to slow down. So when you have a transition metal, look at the Roman numeral. So what charge is this iron going to have? What do y'all think? Yes, because the Roman numeral right here, y'all see this Roman numeral? That's a Roman numeral 2. So it's telling you what the charge of iron is. And then sulfide is S on the periodic table. S has a -2 charge. It's just already on the periodic table. The iron we had to figure out by looking at the Roman numeral. And so then you cross over the charges like normal. And then you can reduce it because they're both 2. So we can reduce that to a 1-to-1 ratio, right? So does that kind of make sense on how we did this one? Give me a yes or a no in the chat if that makes sense. Okay, Megan's got it. Alexander's got some question marks. Okay, we can do some more practice. Basically, the only difference is this Roman numeral is telling us the charge of the iron. So that Roman numeral tells you, like, see how it says iron 2? So that is the charge of the Fe, right? And then the sulfide, we looked it up like normal. When you have a transition metal, you have to have Roman numerals with it. Confirm the net charge is 0, and then we're good to go. Let's do another example here. Let's do copper 3 hydroxide, okay? Copper 3 hydroxide. So the Roman numeral tells us the charge of copper. So what charge does copper have right here? Great job. Great job. Copper is going to have a +3 charge because that Roman numeral tells us. Hydroxide is going to be a harder one to find on the periodic table, and that's because it is a polyatomic ion. This table is in your chemistry reference guide, and I can share the link with y'all here again. Let's see. Well, I have the link shared in the chat in a minute. But when you look through here, you'll see different polyatomic ions. So scrolling down, I see hydroxide right here. Hydroxide is OH with a -1 charge, right? So we need to write down them together, the O and the H this time, okay? So hydroxide is OH with a -1 charge. So what we need to do is cross that over, okay? So when we cross that over, we have the 1 goes with the Cu and the 3 goes with the OH. And so it's gonna look like this. The reason I have parentheses is because anytime you have a polyatomic ion, you're gonna wanna put it in parentheses, okay? And so we're gonna cross it over like normal and see that our net charge is 0. Okay, so I know that polyatomic ions are a little bit more confusing. I do have the link to polyatomics in the slides, and we're about to get to it. So we'll do that too. So when you're writing the name, let's go backwards and talk about how do you make the name. The way you make the name is pretty easy. You just find it on the periodic table and you change the last ending to "ide." So the name of this compound would be strontium nitride because Sr is strontium, N is nitrogen, and you change the ending to "ide." So let's try naming K3P. So what do y'all think the name for K3P would be? What is K on the periodic table? You can also, like, if you would prefer to look it up online, you can also look up this information on like what is K, right? K is potassium, right? Okay, and what is P on the periodic table? We did this one earlier, right? So K is potassium, P is phosphorus, great job. So we're gonna change the ending to phosphide. The ending of an ionic compound changes to "ide" every time. So the name of this substance is potassium phosphide. Let me know in the chat if that makes sense on how we're naming it there. We're finding their names, and you don't have to do anything except write down the name of it. You don't have to show how many there are or anything like that. So K is potassium, P is phosphorus, and so the name becomes potassium phosphide. Let's try this one. So what is the name for Ca? You can also look this up online if you would prefer to do it rather than a periodic table. Although I would think a periodic table would help you more with getting familiar with it. So Ca is calcium, right? What about Br? What is the name for Br on the periodic table? Bromine, right? Bromine on the periodic table. So bromine is going to become bromide. So the name of this substance is calcium bromide. So you just look up their names and you put them together and you change the ending to "ide" for ionic compounds. Is that making a little bit more sense on how we're naming there? I like naming more than writing formulas because for naming, all you have to do is look up the names and put them together. When you're writing the formulas, you have to look up the charges, cross them over, and then, that's how you write the formula. But for naming, all you have to do is look it up on the periodic table. Diane, that's a great question. The metal is always named first. That's a great question. So the K is always going to come first because K is a metal and the P is a non-metal. And so the metal is always named first and then the non-metal after that. That is a great question. If you have a polyatomic ion like this one, let's try naming this. So here's where the polyatomic ion list is, and you guys are going to need this list. It's from table A4 in your periodic table. Hold on, I'm going to go back to it. But I'm going to put it in the chat here. Here's the shortcut for it. So everybody click on this link. This is a shortcut to your polyatomic ions list. It comes from the chemistry reference guide, which is, which I can send the link to as well right here. Okay, but that tells you a list of all the polyatomic ions that you need to know. Okay, so we're going to end on this slide. There's more information, but we're going to stop here. But let's try naming BaNO3. So click on the link I just sent in the chat, the first one, and find NO3. So you should see this list come up, table A4, if you click on the first link. So everybody click on that first link that I sent and see if you can find NO3. Okay. NO3, and put in the chat, even if it's already in the chat, I want to see, like, y'all take your time and find it for yourself, because I know that sometimes it can just go quickly. Nitrate, right? Do y'all see right here that NO3 is nitrate? Okay, so NO3 is nitrate. So you have to go look it up and find it. And then Ba is just on the periodic table. It's barium. So only when they come like in a set, like NO3, do you have to look it up on that list. Otherwise, you can just look up the individual element. So the name here is going to be barium nitrate. You don't have to change anything this time. When it's a polyatomic ion, you do not change the ending of the name. So it's just going to be barium nitrate. Okay. We're going to do one more example, and then we're going to be done for today. So y'all see if you can find this one. So see if you can find CO3 on that ion sheet. Again, click on the link, scroll up in the chat and click on that link that I sent and find CO3. Okay. After you find CO3, we can look up the Na part of it, right? Trayson's got it. Great job, Trayson, on that. See if you can find CO3. It's okay if it has a charge above it. So you might see CO3 2 negative, right? That's okay. That is the same thing. So you should see CO3 2 negative. Okay. So y'all should see right here, I'll share my tab. CO3 2 negative is right here. And that is carbonate, right? Y'all see how that is carbonate? So we know that the that polyatomic ion is carbonate, and then the Na, who knows the name of Na? What is the name for Na? Sodium, right? Great job. Na is sodium. So the name of this substance would be sodium carbonate. We found the carbonate name. You can also look this up online, like CO3 name, if you want to just look up the name of it that way. But this is kind of how you can find it using the resources that we have. So some of you guys had questions that I didn't fully see, like William, what about NO2? If you have any questions, please stay back. But just know that anytime you need help, I can go really slowly with you in my classroom. Like I can take as much time as you need or go quickly with you. So whatever lesson you're working on, whatever question you have, from 9 a.m. to 4 p.m., I'm in my classroom here to help you. And so you can always come in and I will work through the problems with you that you need help with at the pace that you want to go. So you guys have a great day and stick around. If you have any questions about anything in chemistry at all, just stick around and I will